Hello, so today I'm looking at M3 May 2015. This is question 7. So I have a solid smooth sphere with centre O and radius R is fixed to a point A on a horizontal floor. A particle P is placed on the surface of the sphere at point B, where B is vertically above A. So if I just draw a quick diagram, so the centre was O, the point on the floor was A, and the point vertically above A was B at the top. And so my particle begins here. The particle is projected horizontally from B with this speed, root gr over 2 when the radius is r, and starts to move on the surface of the sphere. When OP makes an angle of theta with the upward vertical, so like this, and P remains in contact with the sphere, then the speed of P is B. Okay, show that V squared equals blah blah blah. Okay, so how can I get an equation with V squared in it? Well, I could use energy, and the other option is to use the get an equation with the acceleration in, because the acceleration will be V squared over R, which is a better choice than using R omega squared in this question, because we can see we've got V squareds all over the place. So this is the best thing to use for the acceleration. But I'll begin by using energy and see if that's enough to kind of get me the mark. So if I call this point C, okay, so what I'm going to say is that the kinetic energy at B plus the gravitational potential energy at B will equal the kinetic energy at C plus the gravitational potential energy at C. And I will consider this level of O to be where gravitational potential energy equals 0 for this part of the question. So the mass of the particle, they didn't tell me that. Okay, so for kinetic energy, I'll do half m this squared, so that will give me gr over 4 plus mg times the height above O, so that will be r, equals the kinetic energy here, half mv squared, plus the gravitational potential energy mg. And if this length is r, then I can imagine a triangle here, and this height here will be, this is the adjacent of this triangle where the hypotenuses are, so I need r cos theta to give me this height. Okay, I can see that I have m's all over the place, so I can divide through by m. I could multiply everything by 2, and that will get rid of this so that I can make v squared the subject. So double, 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 double. And now I'll tidy this up a bit. So here I've got a quarter of gr plus 2 lots of gr. Well, 2 lots of gr is 8 quarters. So here I've got 8 quarters gr plus 1 more quarter of gr. So I've got 9 gr over 4. Then I'll bring this over to the left hand side by subtracting 2 gr cos theta from both sides, and that will give me v squared. Now I'll just compare that with what they said. They want gr over 4 out as a common factor. So if I take gr over 4 out as a common factor, then here I will be left with 9. This, I need to think how many quarters is this. 2 is 8 quarters, so there I would have 8. The g is there, the r is there, the 8 divided by 4 will make 2, and now I just need a cos theta. And that hopefully is the same as what they had. Yes, it is. So that's my first 4 marks. Okay, then part B. In part B, they say the particle leaves the surface of the sphere when theta equals alpha. Find the value of cos alpha. So when the particle leaves the surface, then I know that at that particular position, the reaction here will equal 0. I know that I'll have the weight acting down, and the acceleration towards the centre of the circle will be the speed at that point squared divided by the radius, which is r. So using Newton's second law towards the centre of the circle, I can say that here I've got alternate angles, so this angle is alpha, so I've got mg cos alpha minus r equals mass times acceleration. And if when theta equals alpha, then r equals 0, so therefore this bit can be ignored. So I can work out that mg cos alpha equals mv squared over r. I can divide both of these by m. I can see that v squared will be gr cos alpha. And so actually, were they asking me the value of cos alpha? Okay, so I know that v squared is equal to this thing. Now from before, I also got v squared is equal to this thing, and I know that at this particular position, theta is equal to alpha, so I can just pop an alpha there. So I know that that stuff with an alpha there will equal that stuff. So I get gr cos alpha equals 9gr over 4 minus 2gr cos alpha, and that's just multiplying out these brackets here straight away so I can make a bit more progress. Okay, I can now divide everything by gr. I can add 2 cos alpha to both sides, and so then dividing by 3, then I end up with cos alpha is 3/4. Okay, so that is part B. Then I'm told that after leaving the surface of the sphere, P moves freely under gravity and hits the floor at point C. Given that the radius is this, find to two significant figures the distance AC. Now, if I look back at my diagram, now actually I called this point C, but I'll have to just ignore that. So they're calling C as it leaves here, kind of where this distance here, wherever I leave, is what they want from A to C. Okay, so as it leaves, then I know that the velocity is acting in this direction. I know that alpha and this angle will add up to 90. If I draw in the horizontal, then I know that this angle here is also alpha. So I can work out that the horizontal component is b cos alpha as it leaves the sphere. So V was this thing, and now I can put in R and I can put in alpha. So I know that V squared is GR cos alpha, where G is G, R they told me is 1/2, and cos alpha I just worked that out to be 3/4. And so for V squared I get 3G over 8. Then cos alpha therefore will be still 3/4, so I get that this horizontal component as it leaves the sphere is root 3G over 8 multiplied by 3/4. Okay, so now if I try to just focus on what I want this distance AC. So you had it began here. It moved round to here. So basically, we're only considering with SUVAT the distance that it moved from here down to this point C, which is when it hits the ground. So you've got the surface of the sphere, whoops, and then what the particle does is it just leaves and then will, whoops, it will land there at C, and as you can see, art is not my thing. Okay, right, I hope that's reasonably clear. Okay, now, so what's going on? Well, this is R, this is alpha. So the distance from A to C will consist of this distance here, which is the same as this distance here, plus this distance here, which I'm going to call X. Okay, this distance here, using this triangle, is R sine alpha. Now, if cos alpha was 3/4, then that means that if that's alpha, cos is the adjacent over the hypotenuse, and so for sine alpha I can use this over this. So here I need to do 16 minus 9 gives me 7 square rooted. So here I get the square root of 7 divided by 4. Okay, so AC is going to equal R sine alpha. R is a half times by sine alpha, this thing, root 7 over 4, plus what X is, where X is the horizontal distance that it moves once it leaves the surface of the sphere. Okay, I know that the horizontal component of the initial velocity therefore is this, and the vertical component will be this multiplied by sine alpha. So, okay, new bit of paper, right. So if I look at horizontally and vertically what's going on. So horizontally and vertically. So horizontally I'm looking for X. The acceleration is 0. Vertically the distance that it moved was this height here. So that will be R plus R cos alpha, which is going to be a half plus a half times 3/4, which will be 7/8. Okay, so that's the value of S. I know in this direction the acceleration is G. These are both moving basically from here to here, so down. So basically down is my positive direction. If I look at the initial speed, I said the initial speed was this horizontally. And vertically it will be the same thing, but instead of using cos alpha, I use sine alpha, which was this. Okay. So now here I've got 3 things, which is enough to work out anything else that I need. And here I only have 2 things, so I'm missing 1 bit of information here. So the thing that can link this stuff to this stuff is t, the time that it takes. So here I need to work out t, so that then I can pop it into here and work out what x is. And then I can do x plus this thing to give me AC. Okay, so using these values vertically, then I get S is ut plus half AT squared. So I get 7/8 is that thing. Let's just see if the calculator can make that slightly nicer. I've got square root of 3 over 8 times 9.8 times root 7 over 4. That's not exactly nice, is it? Right, 7 over 80 root 210 multiplied by t and here I've got half of A, half of G is 4.9 T squared. Okay, so I've got a quadratic equation in T. So I've got 4.9 T squared plus 7 over 80 root 210 T minus 7 over 8. So what I'm going to do is just stick these coefficients A, B and C into my calculator in the memories, and then I can just stick the formula into the calculator. So this was the value of B, so I'm going to store that in B. Okay, for A I've got 4.9, store A, and for C I've got negative 7 over 8, store C. Okay, so now I can just type in negative B plus the square root of B squared minus 4AC, all divided by 2A. And so I get that T is 0.3125 ... Okay, I'm going to save that into my memory D, store D, and just make a note for myself of where I stored it. Okay, and now I can use that value of T together with these values to work out S. So again, using S is ut plus half AT squared. Well, this time the half AT squared is going to disappear because A is 0. So I just get X is this times my value of T. 3G over 8 times 3/4. So that was U multiplied by T, 0.3125. And then popping that into my calculator, so I've already got that on my screen, times 3/4 times root 3 times 9.8 over 8. And so here I get X is 0.449 ... And so now to get the final thing that they wanted AC as this. So I just need to do that plus this value of X that I got. So there's my value of X plus a half times root 7 divided by 4. And so I end up with 0.78 meters. Okay, or 0.780 is fine as well. Okay, so I hope you found that solution helpful. Do click like if you liked it. Good luck with your studies.